We're going to go over the integral of some special cases. Now, we have the integral of 4 square root of 4 minus x squared divided by x squared dx. Well, we need to understand if we have got something that has got a root, and then inside we have got x squared minus a certain number that is squared. For example, 2 squared, that gives you a 4, maybe x squared minus 4. This, for you to find the value of x there, to integrate, you need to express it in terms of trig ratios. And so for this one, to find x is going to be a sec theta. Now, if you have got now where you are starting with the a squared and then the x squared, this one, the x, you can express it in terms of a sin theta. Okay. Now, where you have got two of them adding, two square numbers, one should be a variable, of course. To find x, we're going to express it in terms of tan. That will be a tan theta. Alright. So now to find the integral of this one, you can see we are starting with a number and then minus a variable. So it is in this form. So therefore, x is going to be equal to a sin theta. What is a? A is this number which you can see here. The square of this number we can see here. And that is the square of, in other words, 2 squared. So therefore, a is equal to what? 2. So we are going to write x in terms of sin, and that will be 2 sin theta, because a, the number that we squared for us to get 4. Now that we have got this, since we are talking of x squared, we are going to square it. So this is also going to be 2 squared, this will be sin squared. So this is what I'm going to go on and substitute. That is going to be the root of 4 minus, where there is x, I'm going to put x squared. In this case, I'm going to put that, or 2 squared is a 4, and then sin squared theta divided by, I've got x squared down, which is 4 sin squared theta. Now, this very x here, before I squared it, if we get to differentiate it, that will be dx is equal to, I'll first write 2. If we differentiate sin, that gives us a cos theta. Now, this was supposed to be dx over d theta. So instead of me writing over, I'll put the d theta this side. So where there is dx, I'm going to put 2 cos theta d theta. So where here, I'm going to put 2 cos theta d theta. And so this is going to give us the integral. I can factorize out a 4. And then we're going to remain with 1 minus sin squared theta. And then divide that by 4 sin squared theta, and then we have got 2 cos theta d theta. We have got a root here, so shouldn't forget that. The square root of 4, that is a 2, so that will give us a 2. 1 minus sin squared is cos squared, and then divide that by 4 sin squared theta, and then 2 cos theta d theta. Now a 2 can cancel out with a 2 here, that is going to remain with a 2 down, and that which remains can cancel with a 2 there. The square root of cos squared will just leave us with cos theta over sin theta, and then we have got also another cos theta there, d theta. So proceeding from this point, that is going to give us a square root. This is of course squared in the denominator. That is one thing that you shouldn't forget. This was squared, so that is just an omission. This is squared. Now from here we are going to go on, and so this is going to give us the integral of cos squared theta divided by sin squared theta, and then we have got d theta. Oh, I forgot a theta there. Okay, like that. Now cos squared over sin squared, that gives us cot squared theta, and then d theta. When we get to find the integral for cot squared, we are going to get, okay, firstly, before we even do that, cot, from our special angles, we know that cot is the same as cosec squared theta minus 1. When we have got cot squared and then the theta. So at this point, we know that when we have got d over dx of cot x, this gives us negative cosec. Okay, d over dx of cot x gives us negative cosec. That means if we get to integrate cosec, we are going to get what? We are going to get a cot. Okay, so that is what we are going to get. Differentiation and integration are simply reciprocals of each or inverses. So because it's positive cosec, we are going to get a negative cot theta. And then what else do we have? We've got the integral of 1. That will just be, because we're integrating with respect to theta, that is going to be d theta. And then we've got plus a constant c, a constant of integration. Now, at this point, we need to understand something. We are given in terms of x, but we have got our derivative in terms of theta. So we need to take it back in terms of what? In terms of x. One thing that we said at the beginning, we said that x is equal to what? X was equal to sin theta. This is from where it came from. So if we can make sin theta sub to the formula, that is going to give us x divided by 2. So meaning we have got the angle what? The angle is theta. So the angle is theta here. We know that sin is opposite over hypotenuse. So that means this is the opposite to the angle theta. And then 2 is the hypotenuse. How do you find this side? This is going to be the square of the hypotenuse minus the square of the opposite side. So that is going to be it. Now if we are talking about cot, cot is the opposite for tan. If tan is opposite over adjacent, then cot is adjacent over opposite. So this is going to be negative. The adjacent side is the root of 4 minus x squared divided by the opposite, which is x, and then minus, and here I wrote d theta. This is not supposed to be d theta. The integral, this is an integral, so it's not d theta, it's supposed to be theta. That is just a mistake on writing. When we get to integrate 1, we're going to get theta because we're integrating with respect to theta. So now, where there is theta, what are we going to put? Well, we can say that sin theta is x over 2. That means theta is going to be sine inverse of x over 2. Now, sine inverse, we can also write that as just arc sine x over 2, and then plus a constant c. So that is going to be it for this practice. Let's look at another question. Evaluate the integral dx over the integral of x 3 plus root x to the power 3. How do we work it out? So we're going to use u substitution for this problem. We'll say let u be equal to, we're going to get this portion which is raised to a power. Everything that is raised to a power there, that is 3 plus, I can as well say that is x to the power 1 over 2. Okay, what is just here, that is what I've written. So let u be equal to 3 plus x to the power 1 over 2. So if I get to differentiate this, du is going to give me, if I differentiate 3, that will just be 0. And then we are going to have 1 over 2 x. Now the power minus 1, that gives us negative half. Now this was supposed to be du over dx. Instead of me writing dx, I'll put dx this side. If I want to make dx sub to the formula, that is going to be dx is equal to du divided by 1 over 2 and then x to the power negative 1 over 2 in that manner. I can as well write this in much simpler terms. That will be dx is equal to, there is a 1 on top, 1 over 1 over 2. That is simply the same as 2. and then we have got du. Okay, now if this one comes down, we can say that the power is negative. So that means if I take it on top, the power is going to become positive, so it becomes x to the power 1 over 2. Now instead of me writing x to the power 1 over 2, I can also say that is just simply root of x. So now I'll come back to the integral. That will be the integral of where there is dx. I'm going to put 2 root x du, and then divided by where there is root, where there is 3 plus root of x, I'm going to put u, and that is raised to the power 3. So we can see that this term cancels with that term, so that leaves us with the integral of 2 divided by u to the power 3 du, like that. I can take this one on top, and since it's integration, I can remove this constant away. I'll put it outside the integral symbol, and then I'll take u on top. It becomes a negative power, and then you have got du. So this is going to give us 2. Now the integral of u to the power negative 3, that is simply u negative 3 plus 1, that will be negative 2, divided by negative 2. And then we just add the constant of integration. See, we go back now and substitute what our u is. We said u was equal to this portion, so that would be 2. Well, I've noticed one thing: the 2 and this can divide, so that will leave us with only a negative u to the power negative 2 plus c. So we'll just go on now, substitute negative where there is u. We're going to put 3 plus root of x to the power negative 2, then plus a c, like that. Now because it's raised to a negative power, I can take it down. This will be negative 1 divided by 3 plus the root of x, and then the power becomes positive, and then plus a c. So that is going to